All right, let's get started. All right, let's see. First I'm gonna go through, update my README, look at what we're gonna do today. Okay, so today it's day 5 of 100 Days of ML. We're going to be deploying our ML model using Docker. Just as a review of what we did yesterday, we got stuck on a problem where we were deploying our ML model, deep learning LSTM model onto using Streamlit. However, while loading our code, we got into an error called type error with vocabulary size as a key argument that's not understood by the model. So I've posted a query on Stack Overflow, and we'll wait until someone gives us a reply and helps us out with this issue. Till then, we'll continue. So today we're going to be continuing to deploy an ML model using Docker. Previously, we've done all of our deployment using Flask and all of that stuff, but we haven't really well, it's kind of like the same thing. I've been reading up Docker yesterday and today. So basically, Docker is just like an additional feature. Suppose, for example, like how we had problems earlier on in this 100 days of ML, we saw that we had issues with running TensorFlow on our local machine, on at least my local machine, because the versions didn't match up. And especially, I think in day 3, we had an error with our deep learning model where it wouldn't run because we were using TensorFlow 2.4.1. However, when we upgraded to TensorFlow 2.5, it immediately started working. So there's a lot of issues with like different software running on different applications, and all of this can change based on like what OS you're using and what software tools you're using and what versions you're using. In order to basically package all of your code into a bubble, we use something called Docker, which was created by Google. So we can basically containerize all of our code into this Docker container, and our container will be protected from global variables. And so this container, no matter like where it is, it'll run on your system. So you could also containerize, you can also run multiple instances of the application. So it's very nice to, a nice feature to like scale up your application. Yeah, that's what I've learned so far. So that's a summary of Docker. So we're going to be creating a Dockerfile. It's not going to be a Streamlit application. We're going to be doing a Flask application today. So we're going to create a Dockerfile. We're going to use the same linear regression model from earlier using the wine quality dataset. And let's see, so we'll continue and we'll deploy this application. We've already created the Flask application for it. So I think all of this code can be replicated. In fact, I'm just going to use the same directory. So I'm just going to create a Docker image and a Docker file, and then I'm going to build the Docker container and Docker image. And then I'm going to try to push my image to Docker Hub. And yeah, so basically this allows any user to kind of pull the Docker image and not immediately run the container on their system. It also makes it very easy for me to deploy the application onto a cloud server, and it would be easily scalable. So that's a brief summary of what we're going to do today, and I'm just going to go over chapter 4 again. So machine learning deployment using Docker. So what is Docker and why do we need it? Yeah, so Docker is kind of like a container, as I explained earlier. Okay. So yeah, it's a computer program that performs operating system level virtualization, known as a containerization. So no matter where it is, your laptop, test environment, staging environment, production environment, all the container is going to remain the same, and no matter where you deploy it, the code is going to run and have the same result. So as opposed to a virtual machine, which has a hypervisor, here we're just going to have a Docker server, and the Docker server maintains the applications, the container app. So we have different sections: Docker images, Docker Hub, Docker Server, Docker Client. So Docker images are kind of just like the blueprint. And once you use that blueprint, you can build containers. Docker Hub is basically where you can store Docker images and also publish it to the internet for anyone else to pull, kind of like a GitHub repository. Docker Client and Docker Server, just CLIs for building Docker and using Docker in your terminal. So some of the popular commands for building Dockerfile, going to be going over this. Docker Hub, Docker Client, and Docker Server. Docker Server is just a server that runs in the backend that creates maintains all of the containers and also deploys it. So you can see that it fetches basically in your system. You're going to have a bunch of images, and we can check this out by running docker image ls. And so in my local system, I have about a couple Docker images in my image cache. And also, if we don't have what we're trying to look for in our image cache, we can also get it from Docker Hub using Docker pull. Okay. So yep, we can see this is a nice graphic that shows that Docker images are just like kind of like the blueprints, and we can use that one blueprint to build the same house multiple times. And the container is kind of like the house where it contains the same environment as what the Docker image states it to be. Some popular commands. Okay. All right. So let's start containerizing, building our Docker container for our Flask app. So we'll go to our Flask app directory, and here what they do in the textbook is they create a new model and then they deploy it using oh, actually, I might actually want to create a new repository for this because they use a new UI software. They use something called Flasker. It wraps around this Swagger, I guess. And yeah, let's do this. So under Flask development, we're going to create a new folder. We're going to call this, let's call this like Flasker app or something. And we're going to want to create another folder just for the regular. And we're going to have to move all of this. It'd be easier if I go through here. We'll move all this code into regular. Okay, there we go. Okay. Tidies up everything. And we're going to be using the pickle file, the same pickle file. So we can copy this and paste it into our Flasker app. Okay, and all right, so now what we have to do is create this new UI using Flask. So we'll call this app.py. Okay, so from Flask, import Flask, and request for numpy as np, import pickle, and s. I think a majority of our code is going to be very similar to the regular app. Oh, there we go, yeah, this one. So let's check it out. How do we do this? So here we use joblib, I believe, to open our model. Pickle open. So we opened it and loaded it. Load. We did joblib.load. Here they're using pickle.load. I don't think there should be a difference. They have the root method, predict class, predict file. They have two different predictions. Let's see, where are they creating the UI? Here they're using docstring. So we kind of want to, in the future, come back to this and put in docstring to our code. I think it's right here. Oh my god, there's a car beeping outside. That's annoying. I don't think it's being picked up on the microphone. Alright, let's copy and paste this for now. And we'll make changes as necessary. So app, Flask, and then we're going to do wrap it using Swagger. And I think that's pretty much it. We just wrap the Flask app and everything else remains the same. We do need this templates folder. Alright, I think that's pretty much it. Let's go to our terminal, cd into Flask development and our Mr. app, and then do Flask run, I believe it's app.py. We might need to, how do you run it? Oh, okay, so since we're using our Docker image, we're going to be using app.run. Right, we do use app.run, and we have to specify the host. I think it's just general host. Could be anything. That's what it means. So next up is the Dockerfile. Right, S export Flask app. And then we're going to call that app.py, I think. Or do we just call it app? Let's go Flask quick start. Yeah, I mean, it should be Flask app.py. And then we can do Flask run. What's wrong here? Oh, why is it empty? Okay, I see. I copied this into the wrong file. We can delete this, I think. This doesn't really matter. There we go. I'm gonna have to pip install Asker. Flask run. Open up our, let's see. Server's now loading up the model. Why? Okay, first of all, numpy should be np. Render template, okay. What's wrong here? So template, render template is not defined. Where is render template in this? Render template. Okay, so we need to include render template here. All right. This UI looks the same. Not sure what Swagger is doing here. Or is that only used for like documentation? Do I need to include doc strings? Let's try doing that. Let's see. Response is a render template. Okay, let's search up what does Swagger do. Okay, I think I pip installed it incorrectly. So do I just set up the app development and start it? So I guess I have to just start it regularly, not as a Flask app. iPhone. And it should open up. Python, blah, blah, app.py. Set doc strings for this. I'm not too sure what's going on here. I use app root prediction test file. There's nothing in this method. Read CSV, that's it. Prediction, predict, return str list prediction. So I guess we don't need HTML. So let's not render the template. Dash predict method is get. Okay, predict customer would want to buy a product or not. So this is kind of our predict method. What it returns is just a string. So yeah, we're going to return a string here. Oh no, that's if the exception happens. So we'll do return what we're going to return is a string plus a value of this model predict. Cast this variable into a string just to be safe. So this is definitely not Flask. Okay, we need to return something here. I don't even think we need to include a root homepage. Okay, let's see. URL not found. What did they do here? What did they put in their... So Swagger, they wrapped the app around it. They loaded in the model. Sure, I could do this outside as well, but I don't really think that makes a difference. They have their predict, the method post and get. I have post. The prediction class. Let's write the doc strings for this. Parameters. So we have alcohol. Inquiry type number required true. Okay, so hold on, why isn't this lining up? Query type number required true. Okay, I think this is name. The name is alcohol. And we have to do the same thing for the other variables. So we have alcohol, volatile acidity, sulfates, total sulfur dioxide. Total pages visited. Yeah, sure, that's their query. So responses 500 and prediction. Print prediction. And at the end of this, what we're doing is returning the predicted value. So let's see how this looks. Did I stop the... Still nothing. Debugger is a term. So the command is just Python and then whatever the name of that file is, .py. That's how it's run. But I can't even seem to get this running locally. So what it's supposed to look is like this. Environment production, deployment server, blah, 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 blah. Debugger pin, yeah, sure. HTTP 5000, API docs. Oh, okay. Internal server, errors. Failed to load API definition. Okay, I guess this ties in with what we're trying to do with, what was it? Doc strings. So that's good. Where is it? Logging, documentation. I'm going to be reading this. Okay, so I guess the first is just explain what the method is. Usage. You could write a little bit of an example. Note, arguments, raises, returns. This in Visual Studios. You could automatically just do everything. mkdocs. API docs, docs, API DOCS. That's what we have going on. Localhost 5000. It should show the get and or we should just have like a post. No, we should have both, the get and post for our method. API spec underscore one dot JSON. It's not finding this? Is that what's going on? Did I miss something in the code? We are returning a string. Cast this again into a string just to make sure. App run. Return root. Okay, then what's the problem here? Oh, it's okay. Mapping values are not allowed in uni-string. I mean, isn't that exactly what I followed here? Spacing matter. Oh wow, the spacing does matter. Okay. Cool. So Swagger API, powered by Flask. You can see the docs here. The get and post. So post, we could try this. Kind of just like test our application. Try it out. And specify values, I guess. And then execute responses. And we got a response error, internal server error. Fortunately, we got an error here. Float must be a string or a number, not none type. Request rx.get. Request rx.get. Okay, so now it's not a form anymore. It's getting it from arguments. Whoa, I'm lagging out. These values are totally random. So yeah, does work. Response 200, and the response body is a this output right here, which is a string. Okay, cool. That concludes the first part, at least making everything work in terms of the application. Now we're going to try to create the Docker image by specifying our Dockerfile. So Dockerfile, we're going to run the pump command. So this is going to be our base image, which we're going to modify. Let me just check this out, what it is. Powerful and flexible. Bootstrap installation of Anaconda. I guess it's just a Python environment. 100 of the most popular Python packages for data science. Okay, cool. So we'll use that as our base. Next, we're going to copy in our directory. Copy usr ml. We're going to name it app. We're going to create a new directory called usr ml app in the Docker, basically the container when it runs. Next command is to export port 5000. Expose 5000. We'll specify our work directory. usr ml app. Next step is to install the dependencies and the required libraries. So we're going to have to create our requirements.txt. And in our Docker file, we're going to run that. Pip install requirements.txt. And in requirements.txt, we have to specify all of the imports. I think the only extra ones we have to do is like, how do we even specify the contents in the... No, we'll finish that later. Forgot what's the format for specifying libraries in .txt. So we could do something like, what do we need? We need Flask, Pandas, NumPy, scikit-learn, joblib. That's all we're using. And we'll avoid specifying the versions. I don't know if that matters. We could do that. Flask. So 2.0. Just want to use the latest versions or whatever the 3.4. Point 0.3. It's 0.24.2. Cool. That's our requirements.txt file. And then what we're going to do is specify the command to run when our container is up. So that's python app.py. So this is our Docker file, and we're going to build this Docker file now. We're going to call it ml app_docker, and let's build it. I think the dot just refers to all of the files in the current directory. So we're getting the base image first from Docker Hub. And then it should be building our custom image by running the Dockerfile. And then we can use the Docker container after it's built to run our application on port 5000, which is going to be the same thing that we just tested, but it's going to be running on a Docker container. All right, let this run for a little bit. We can shell out. Okay, we have a problem with specifying pandas. What's my pandas version? Oh my god, where is it? Alright, let's build this again. Hope that we don't get this error. NumPy version, let's change that real quick. Alright, change didn't go through. Good. Alright, NumPy worked. Okay, now scikit-learn's not working. What's our scikit-learn version? Let's just use this. Get an error with job lib. I'm just not going to specify. Okay, I'm not going to specify the scikit-learn version. Should be the same. Scikit-learn doesn't really make very drastic changes to their code base. All right, so that worked. And we can check Docker. And that's our container, I believe. No, this is our container. Okay. What are all of these none? I'm not sure. Might have to delete or clean the system. So we can run the Docker container now. Docker container run publish port 5000, 5000, and the name of our image. Module typing has no attribute return. It was just working. What was wrong? Did I make any changes? Did I forget to include Flask here? No. Python 3.5. I'm pretty sure the Python I'm using should be not too sure. Okay, so I need to specify a new Python. Let's see. Should be in my API. Dockerfile. Okay, so we're using base as Python 3.7 instead of, let's use that instead. Boom, boom, boom. Over export. I don't think we need any of this other stuff. Rebuild our container. Actually, let's remove. And then let's rebuild. All right, I'm optimistic this time that it will work. Oh man, did we forget to include this? Yep, we did. That's awkward. Okay, let's remove again the image. Let's rebuild. All right, our container is built. Let's. Oh my God! Oh no no no! Don't build it again. Okay, run the container. Come on. There we go. That's what I'm talking about. We go here. Not this. This and refresh. Yes, it works. We saw the request coming in here. Awesome. So I guess that concludes it for today. Just a revision. What we did was use the same linear regression model that we trained at the beginning. We used the pickle file. We loaded it using Flask. We wrapped it with Swagger, which seems to be like a cool, easy documentation type thing, API, where you can visually see the different requests going in, and also becomes very easy to test and figure out errors, prototyping, testing, stuff like that. We also put in the doc strings, which I think is pretty important for this. It sets up the Swagger like documentation, I guess. And then what we did was we built a Dockerfile, and using this, we created a Docker image by building it, and then we ran the container locally. So right now this code is running on a container. So I want to learn how to push this to my Docker Hub. So push an image or repository to a registry. So let's do that. Okay, we need to Docker, yes, Docker kill, and then we'll kill our container here. I think that's the last part. Stopping and killing the container. Okay, Docker image us. So I want to push this to my Docker Hub. Docker push, and if I just paste the ID, would it work? The push refers to a repository. An image does not exist locally with the tag. Oh, okay, what's the tag? I guess it would be something like this: Docker push, the name, and our tag is just latest. Yep, that seemed to work. Request access to resources denied. Do I have a Docker ID? I have no idea. I think I need to check. So I guess I need to sign in to the terminal CLI and then I would be able to push it. Otherwise, it doesn't know where to push the container to. All right, I'm going to be doing that off stream. That concludes it for today. Let's just go over the goals for tomorrow and update the README. Okay, so ML deployment using Kubernetes. So I'm going to have to read chapter 5, which is basically the last chapter in this book, ML deployment using Kubernetes. And I believe we're going to be creating a GCP project. And using one of the microservices on the cloud, which is the Kubernetes engine. There we go. And using that, we're going to basically deploy a container. Yeah, I believe so. We're going to learn more about Kubernetes. I have no idea how it works. I kind of have like a basic intuition. There's a worker and there's like a node part, but I'm not sure how it works and what the point of Kubernetes is. So yeah, a master and a worker. That's what it is. All right, cool.